Hey guys, welcome. We are in our quadratic chapter and we are going to be talking about quadratic graphs and their properties. So why don't we go ahead and start out by writing this heading, quadratic graphs and their properties. And today our objective is to graph quadratic functions of the form y equals ax squared and y equals ax squared plus c. Okay, so let's get to it. And scrolling down. Boom, this is the good stuff right here. Okay, so we're going to do a bit of writing. Hope you're ready. Let's read this first part. Essential understanding. So a quadratic function, what is it? It's a type of nonlinear. Linear means straight line, so this is not going to be linear. It's going to be curving. That models certain situations where the rate of change is not constant. Think of when you throw something up in the air. It goes really fast, slows down, and then picks up speed as it comes back down. So the graph of a quadratic function is a symmetric curve with the highest or lowest point corresponding to the maximum or minimum value. Okay, this is where we're going to get into writing down. Whomp all of that. Yes, all of this needs to be written down. Okay, so standard form of a quadratic function. So a quadratic function is a function that can be written in the form of y equals ax squared plus bx plus c. We've talked about factoring things that look like this. We call them trinomials. But now we actually have an equal sign, so now we can call it a function because we can plug something in and something can come out. It's a function. This form is called the standard form of the quadratic function. Here's some examples. Notice the x squared is the first thing and the normal x is later. The simplest quadratic form is x squared or y equals x squared. We call it the parent function because from the parent function we can move it around up and down, widen it, and we can also flip it upside down. And here's the example of the parent function right here. And then the graph of quadratic function is a U shape. We call it a parabola. And this is it. It's not really a U, but it's U in shape. And that's a parabola with the equation y equals 2x squared shown to the right. You can fold a parabola so the two sides match exactly, so it's symmetric. And we have a thing called the axis of symmetry. Okay, so make sure all that's written down. Very crucial key things. All right, let's move on. Okay, and then our last bit of information is right here is that we're going to have to get all this stuff in there. Oops, wrong thing. All this and all that. Okay, so the highest or lowest point of a parabola is called its vertex. Okay, so the vertex is where that changes. In these examples, you don't have to write them down, but that's a vertex. That's a vertex. It's when I change, I'm going up, and then when I change to go down at that highest point is a vertex, or if I'm going down, and then I'm about to go up, that point changes the vertex. Okay? If A is in front of it, we're going to have a minimum. It means my graph is going to be a U shape like this. And if A is less than 0, like a negative, then my graph is going to have a maximum, and my U shape is going to be like that. So write all of that down right here, but not problem 1. And we'll get to some examples. Let's go. Okay, number 1. Let's get this one down. What are the coordinates of the vertex of the graph? Is it a minimum or is it a maximum? Well, right where it changes is right here, and that point is at an x value of 0 and a y value of 3, so there's my vertex. And is anything above this? No, so this might be the maximum. Is there anything below it? Well, yes, so it's definitely not a minimum, so this is a max. So a max is when you have a parabola of this shape, whereas a minimum is going to have a parabola in the upward shape. Okay, and we found the vertex pretty easily. Okay, make sure you write the words, these little U's, the picture, the graph, and the point. And our final answer was the vertex of 0, 3 is a maximum. Okay, graph the function y equals negative 3x squared. Okay, so the way we do this is we can go ahead and we're just going to draw a nice little graph over here. Okay, and what we want is our table. Our table is going to be y equals negative 3x squared is the function, and then we can pick values to plug in for x, and we're going to get something to come out, which is our y. So it's an input. Again, functions, we input something and something comes out. So let's pick some pretty easy numbers. I'm going to do 0, 1, and 2 and see what happens. Okay, so 0 for x is 0 squared. 0 times negative 3 is going to be 0. So we get 0, 0. So we're going to be right here at the point 0, 0. Nice. When x equals 1, we're going to get negative 3 times 1 squared. And 1 squared is just 1. And 1 times negative 3 is negative 3. So we're going to get 1, and then negative 1, 2, 3. And then we're going to get negative 3 times 2 squared. That's going to be 4. 4 times a negative 3 is a negative 12. Oh, so we got 3. Oh, I think I was off one. 1, 2, 3. No, I'm right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, 2. That goes down quickly. So this right here is part of my graph, but it's not the whole picture. So 3 points doesn't really give me a full picture of this. But what we can do is we can use what's called the axis of symmetry. Now, we're going to talk more about how you find the axis of symmetry quickly, but these early ones, when you have nothing on it, the axis of symmetry is really easy to find. What happens when we actually do negative 1? If we were to put negative 1 in here, well, what's negative 1 squared? It's 1. So when we do negative 1, we actually will go ahead and get negative 1 squared, which is a positive 1, times negative 3. We get the same value at negative 3. So it's symmetric. And then same thing, negative 2. We plug in negative 2. But when you square negative 2, that's a 3, sorry. When you square negative 2, what happens? You get positive 4 times the negative 3, which is a negative 12 again. So we end up way down here for number 2. And so we can see that if I draw in a highlighter, we're going to get, that's not the highlighter, okay, we're going to get a nice line of symmetry. I could fold these over and I could go ahead and take care of them. And last but not least, we're going to find our domain. Our domain are our x values. Well, notice how the graph is going down, but it's going outward also at the same time. It's going to go down forever, but since it goes outward forever, our domain is going to be all real numbers. So the domain is going to be every x value. The range, however, well, it doesn't go above what? The maximum value is 0 on the y-axis. So my range is going to be basically anything above 0. So, or sorry, anything below 0. I'm sorry. So y is going to be less than or equal to 0. So anything below it will be our y value. Okay? All right. Let's see what else we got. Okay, real quick. This is the same problem. You don't have to write this down, but I thought this was kind of cool. Which one of these makes the most sense? Well, we already did this problem, and ours went downward. And again, it went downward because you see that negative 3? That negative 3 makes it go down. So we talked earlier about the minimum and maximum. So if the a value, the number right in front of x, if it's negative, we're going to be sad. If it's positive, happy. So our correct answer is the one that we got, obviously, because we did it right. And again, all real numbers. And then y is going to be equal to or less than 0. Okay? All right, we're going to leave it at that for right now. Let's just kind of do a little basic little intro. We'll talk more in class. But anyways, other than that, toodles. I hope you have it ready for me. And peace out, home slices.